All right. AOC, Advent of Code, day 5. It was brutal. That's why I'm uploading day 5 on day 6. Lots of complicated parsing, lots of complicated logic. So, to avoid this being a super long explanation, let's just jump right into the code. All right, supply stacks. So, as soon as I saw this, I was like, yes, stacks. Stacks are easy to deal with. The logic of them makes sense, blah, blah, blah. No, I made a mistake. So basically, you've got stacks of items, and you've got a list of instructions. And the instructions are move X crates from Y stack to Z stack. So you can see that right here. Only problem is, one of the problems is constructing the stack itself. So here's my input. So if you're familiar with dealing with complex or less than structured text files, you'll know white spaces like this, like multi-white spaces, are an issue. Here's why. If I want to split this string up right here, it seems like it would be pretty easy. Just split per each space, and then I'll have each letter. Now, if I split per each space here, I'll have a space on this side, split, and a space on that side, and then another space. Okay, so these blank spots right here, if they were filled with like X's, for example, no problem. No problem at all. It would be easy. Like it would be very, very simple to set up the data stack. Instead, they've got these spaces right here. So those spaces kind of, they made for a more complicated time. Then after that, we've got moving 5 from 4 to 5. So here's one problem. They are indexing the stacks 1 through 9 instead of 0 through 8. So that's one kind of like a mental thing that you've got to get through. You've got to make sure that you're doing your subtraction correctly. And you're moving multiple things at a time. So per each instruction, you're moving multiple boxes probably. Sometimes it's just one box. But since it's multiple boxes, then you've got to do multiple pops and multiple pushes. Okay, so if you're envisioning a stack, you can this is actually a fairly decent way to explain how stacks in computer science work. Because if you're dealing with low level like assembly code, it's especially important to understand the stack. So the way stacks work is you've got an SLW, and if you were dealing with a stack of boxes up on your desk, you would have S on the bottom, L in the middle, W on top. I'm not going to go for S on the bottom first, because the whole stack's going to fall over. That wouldn't make sense. I'm going to pop W off the stack, then pop L off the stack, then pop S off the stack. So this continual pop, so if I were to pop each and every time, for each and every item on the stack, the new stack that I am pushing onto would basically be the reverse of the initial stack, if that makes sense. So SLW would instead look like W. L would stay the same since it's in the middle, and S. So that would be the reverse of that stack. But instead, we are taking items off of one stack and onto the other. So we're going to move, so for this first instruction, let's say move 5 from 4 to 5. So here's number 4. We're going to take 1, 2, 3, 4, 5 of these and put them onto stack 5. So I would stack them up, but I would stack them up in the order of stack operations. So B would go next, then G would go on top of B, then N would go on top of G, etc. So with that in mind, let's look at the solution for the first part. The first part is simply follow all of the instructions according to how stacks work and rearrange everything. So this I actually don't need. I was using my own custom implementation of a stack for some reason. Don't really know why I did that. But that is entirely unnecessary. You can just use normal vectors and strings and such within Rust. So we can go ahead and get rid of that was 21 lines of code for my solution right there. All right, so for my solution, I had planned on doing it differently. Instead, I've got basically everything within construct stacks and construct stacks 2. You will see the reason why in part 2. So part 1, we're going to get the stack base. What I mean by stack base is this right here, basically where all the numbers are. So this is going to form the foundation of the stack. Everything above that is going to be the actual construction of the stack. I am not going to actually worry about their labels. You'll see that I basically throw those out. So we're going to get the stack base right there. So basically, while the length of the line is greater than 2, if we go back here, this right here is just a new line. So we're basically going to the first iteration of only one character on a line, if that makes sense. So basically, we're looking for that new line by default. So we're iterating over each and every one and waiting until we find that stack base. Stack base is actually one more than that. So right here, we basically get to this line, and instead we're paying attention to line 9 here. So we find our stack base. Then we are going to split that stack base into spaces so that we can get the amount of stacks that are in there. So after we split this on spaces, we are going to have 9 different items within that, that initial split right here in base split. It's actually double space. Yeah. So double spacing. And that will give us the amount of stacks that we've got in the problem. And then we move on to actually loading in our stack. So we're going to start from the stack base right here. Actually, no, we're not. Yeah, we are. So this is initializing the stacks. So we are starting from our stack base -1 because we're only worried about the boxes themselves. Like I said, I basically threw out this line. This line was only used to figure out how many stacks we've got in our problem. So we're starting on line 8 here. So for each line, we're going to split it into bytes. And then for each byte, we are going to run through and check to see if we are talking about an item that we're actually worried about or a white space. If it's an item that we're actually worried about, we're only going to push the letter. So basically what we're going to do is we're going to split this up into a left bracket, a letter, and a right bracket, and we're only going to push this letter right here. Okay, so we're pushing that onto the stack that we are actually tracking. The way that we're tracking the stack is each and every time we hit an item, or we don't hit an item. So if we hit an item, that would be this right here. If we don't hit an item, then we've just got blank spaces. We're going to iterate, or we're going to add 1 to the current stack that we're dealing with. And then we're adding 4 to the current item. So what this is called chunking. Basically what I'm doing is I'm walking through this line by chunks. So here's a chunk right here, left bracket S, right bracket, and then a space. Then we've got another chunk, left bracket J, space, and we've got another chunk, etc. So we're iterating over 4 because we're not worried about this space right here in the middle. So we're skipping over this character, this character, this character, and the space. So we're breaking it up into chunks. So for each chunk, if it's nothing, if it's this white space right here, then we're just not going to do anything. If it's an item, then we're just going to push that string. And after that, we're going to end up with our clean looking array of characters. So I believe you should be able to see it in the solution. Yeah, so here's your stacks right here. So we've got SLW, JTNQ, SC, H, FJ, blah, blah, blah. And if we look at our input, SLW, JTNQ, let's actually throw this over here. If we compare the two, basically this is just a stringified version of this input right here that we can actually work with. Now, here's for another fun part. We're going to actually start working through all of the moves. So first off, we get our array of moves right here, and we get our move index. We are going to start marching through those moves for current move and moves, and we are going to actually parse that out. So this is just checking to make sure that we don't have that new line at the end of the file. Basically, every single move should have multiple words in it because we split that up right here by words. So if we look at our input right here, we are splitting by space. So we'll have move on the left, 5, a space from, space 4, space 2, space 5. Then we start parsing them. So obviously the amount of crates that we're moving is going to be number 1 in that split. The from index is going to be number 3 in that split, and the to index is going to be number 5 in that split. So we print out our stacks here, and we print out that debug that you saw just a second ago. Let's see, solutions 1. So if you look at that debug, this is the like before the operations. So you've got our actual move here, and then you've got the from, the to, and the amount. And then we're going to actually do the operations. So basically we're looping over for each time that we're saying we are going to move, or for each crate that we move, we are going to pop from the from stack into this popped variable, and then we are pushing that onto the to stack, and then we are iterating our counter. So then we get our after operations, and then we will print out what is at the top of each stack. So we'll just pop off the top, and that is the answer. So if we go over to the prompt, I don't think it'll be in the prompt actually. It'll be at the end of solution 1. Let's see. That's the input, sorry. The end of solution 1, we'll get RLF, NRT, and FB, and that is the top of each of those stacks. Now, solution 2, or part 2, is essentially the same thing with a addition that makes it seem like it won't be that complicated. So we've been working with normal stacks here. So you've got a stack of blocks. As soon as you pop something off of a stack and put it on another stack, and then pop something off the stack, you're reversing that stack essentially. Part 2 said no. Instead, when I say grab 5 items off the top of the stack, retain their order. So if I've got 3, 2, 1, we are going to pick that stack up and place it on top of another stack, retaining the exact same order. 1 will be on top, 2 in the middle, 3 on the bottom, or the reverse, whichever one I said. So that actually makes it a little complicated. You wouldn't think so, but it does. The good thing is the initialization is the exact same. So pretty much like 50% of the code could be broken out into its own function to actually construct the stacks correctly. I didn't do that because I'm exhausted with this problem. But if we look over at the moves, the big difference right here is we are pulling off that chunk. So the chunk meaning from the amount to the end, so basically the top of the stack from the like nth item. And then we're reversing that, because if we were to pop in the order that we're pulling it off on, it would reverse the stack. Instead, we want to keep the same exact order, so we reverse it, and then we pop off. So if we take the list, so if we have ABC, and we pop it, we're going to get CBA. We want to reverse that and retain the exact same order, ABC. So then we do all of those pushes as normal, push them onto the from, blah, blah, blah. The big addition here is because I created basically a buffer that held the items that I wanted to pop off into the new stack. So the chunk right here only contains the characters that we want to pop off of the from and add on to the to. We reversed that so that we could retain the same exact order as we popped it off into the to. The problem is we are not actually popping off of the from in that case. We're creating a copy and popping off of that. So we've got to make sure that we also pop off of the from. The good thing is the from stack, you don't really need to worry about the order there. You're just popping off and throwing them away essentially because you've created this copy right here. Okay. Things that I learned about Rust. Vector operations can be kind of tricky. Stacks can be a pain in the ass, and logical, like things that seem logical in your brain are a lot more difficult to translate into code than you would think. That is less of a Rust thing and more of a programming in general thing. Like whenever you visualize, I'm going to move stacks around, that seems like it's fairly simple, but then when you actually try to like code the implementation, it's significantly more difficult. Okay, so this is the first advent of code that I've had to push to a new day. I literally worked on it for like 3 or 4 hours last night, didn't get it, and then worked on it for another 2 today in order to solve it. So I'm going to put out this one today, and then I'll probably do a twofer tomorrow for day 6 and day 7. So just know that I'm trying. If I haven't uploaded something, it's because I'm probably still banging my head against a laptop screen. Take it easy. Glad y'all have been enjoying this series. Peace.